Hi, welcome to the series of video lectures on microwave engineering. Today in this session we will discuss what is gun effect, gallium arsenide diode. Gun effect in gallium arsenide diode. See, this article comes in unit 6 of microwave engineering subject. See, what is this gallium arsenide? So, gallium arsenide is a compound material which is formed from third group by mixing third group elements and fifth group elements. By the combination of third group and fifth group elements, this gallium arsenide compound semiconductor material. This is called as compound semiconductor material, gallium arsenide. So, in this gallium arsenide diode, so there are no junctions. So, there are unlike diode, general diode which consisting of a junctions, transistors which consisting of junctions. So, in gallium arsenide diode, there is no junction. There are no junction in fact. So, it operates with hot electrons whose thermal energy is much greater than the thermal energy. See, this is the, let us see what is this gallium arsenide diode. What is the gun effect in this gallium arsenide diode? Let us see. A schematic diagram of a uniform N-type gallium arsenide diode with ohmic contacts at the end surfaces is shown. So this is the gallium arsenide specimen. You can check that there are no junctions in this gallium arsenide specimens. The typical dimensions of these are 75 micrometers length, 100 micrometers width, height 120 micrometers. See, this is the two contacts are ohmic contacts are provided, these red ones. So this is treated as cathode and this is treated as anode, where you can apply the external voltage between cathode and anode. So this is the shaded, this blue shaded line is metal coated contact. You can see this. So this is the drift velocity. The drift velocity, that is electron traveling from cathode to anode. The drift velocity is 10 power 5 meters per second. So there is a strip here, the strip here which is shown here. This strip is shown here near the cathode. So this is called as high field domain. So this high field domain is formed once the electric field across this gallium arsenide diode exceeds some critical value. A high field domain is formed near the cathode as this high field domain travel towards the anode. Now see the gun. So this is about the construction of this gallium arsenide diode. The gun effect diodes are named after J.B. Gunn, who in 1963 discovered a periodic fluctuations of current passing through N-type gallium arsenide specimen when the applied voltage exceeds a certain critical value 2000 to 4000 volts per centimeter. So this is a very important observation which is called as gun effect. So in what is this? The gun effect diodes are named after J.B. Gunn, who in 1963 discovered a periodic fluctuations of current passing through N-type gallium arsenide when the applied voltage exceeds a certain critical value 2000 to 4000 volts per centimeter. So that means if the voltage, if the electric field across these two terminals, of this gallium arsenide that exceeds some critical value, that is 2000 to 4000 volts per centimeter, what he observed? He observed periodic fluctuations of the current passing through this gallium arsenide diode. So which is called as gun effect. See, the frequency of oscillations, that means the periodic fluctuations of current. So that means the current starts fluctuating like this. Once the electric field across exceeds a threshold value, that is in between 2000 volts per centimeter to 4000 volts per centimeter. See, the period of oscillations, in fact the frequency of oscillations was determined by the specimen and not by the external circuit. See, the frequency of oscillations is mainly determined by the dimensions of this specimen, not by the external circuitry that is connected. So this is very important point. The frequency of oscillation is determined by the dimensions, not by the external circuitry connected to this gun diode. So another very important is that the period of oscillations was usually inversely proportional to the specimen length and is closely equal to the transit time of electrons between electrodes. So the drift velocity is over 10 power 5 meters per second. What is this? What is the period of oscillations? The period, so this is the period. Suppose these are the oscillations. the period of oscillations is inversely proportional to specimen length and is closely equal to the transit time. What is transit time? The time taken by the electron to travel from cathode to anode. See the period of oscillations. See, this is the period of oscillations. The period of oscillations, say this is the period of oscillations, that is T. The period of oscillations is closely equal to the transit time of electrons that is traveling from cathode to anode. So this is the period of oscillations. Now let us see, this is the experiment done by Gunn. So this is the graphs. See the current waveforms of a n-type gallium arsenide reported by Gunn. So these are the waveforms reported by Gunn in his observation. See this, what he has done, he has applied a 16 volts amplitude of 10 nanoseconds duration to a gallium arsenide specimen of length 25 micrometers. So he applied a 16 volts pulse of duration 10 nanoseconds to a n-type gallium arsenide specimen of 25 micrometers length. So then what he observed? He observed that a current fluctuations. See, this is current fluctuations. So the current starts fluctuating like this and will come back like this. So this is an expanded view. So the top diagram is an expanded view of this trace. An expanded view of this trace is shown here. Here an x-axis 1 unit is equal to 2 nanoseconds, 1 unit is equal to 2 nanoseconds, and the y-axis 1 unit is equal to 0.23 amperes per centimeters. So this observation, what he has done, he has applied 16 volts amplitude pulse of 10 nanoseconds duration to a n-type gallium arsenide specimen of length 25 micrometer. Then he observed this type of current fluctuations in n-type gallium arsenide specimen. The oscillation frequency he found was 4.5 gigahertz. He found that the frequency of oscillations is around 4.5 gigahertz. One more observation, Gunn also observed that from Gunn's observation, the carrier drift velocity is linearly increased from a 0 to a maximum when the electric field is varied from 0 to a threshold value. You can see that. So this is the electric field axis, very important, this diagram also. So this is the electric field axis, this is the drift velocity axis. Once you increase the electric field, the drift velocity generally starts increasing, because the drift velocity is equal to, you have this formula, the drift velocity, if electric field increases, the drift velocity also increases. So we have this formula in semiconductor devices, drift velocity is equal to mobility into E. If you increase the electric field, the drift velocity also increases. So if you increase the electric field across the specimen of gallium arsenide, see the drift velocity also starts increasing. Once the electric field, applied electric field reaches a threshold up to threshold value of electric field, this drift velocity will increase. When the electric field is beyond the threshold value for n-type gallium arsenide, the drift velocity is decreased and the diode starts exhibiting negative resistance. See, once around, you can see 2 to 4 kilovolts per centimeter, that is what we have said. So 2000 to, that is 2000 to 4000 in between volts per centimeter, that is electric field across 2000 to 4. So after the threshold voltage, see, you can see after the threshold voltage, the drift velocity in the device specimen starts decreasing. And once the drift velocity starts decreasing, the device n-type gallium arsenide starts exhibiting negative resistance region. So this is called as negative resistance region. So once the drift velocity in the device decreases, the mobility of charge carriers decreases and the current density decreases, and hence the device starts exhibiting negative resistance region. So this is very important graph. Up to a threshold electric field, the drift velocity increases. After the threshold voltage, the drift velocity of electrons in the n-type gallium arsenide starts decreasing. So this is what you have to write. What is Gunn effect? What you have to write is that in Gunn effect, the current in Gunn effect, what you have to write, this paragraph you have to write what is Gunn effect. The gun effect diodes are named after J.B. Gunn, who in 1963 discovered periodic fluctuations of current passing through n-type gallium arsenide specimen when the applied voltage exceeds a certain critical value, which is 2000 to 4000 volts per centimeters. So this is called as gun effect. So this is all about this gun effect, very important topic in unit 6. Thank you.